Okay, so in section 8.6, in our last YouTube video, we talked about common logarithms. We're going to continue that topic today. Base 10 logarithms are called common logs, and you guys already know this. The expression log base 10 of x is usually written without the subscript as log x. We use the log key on your calculator to evaluate common logs. Now, we have, up until now, we've done a lot of different logs with a lot of different bases. But not all calculators have that special log base feature, right, that we've seen. If I go ahead and show you guys again real quick, go ahead and get your calculators turned on. If you hit the Math button, under Math, scroll up to option A. Some of you don't have this, so don't worry if you don't. We're going to talk about something that you could do besides this today. But if you have it, hit Enter, and then in turn, you guys can basically take any log of any base imaginable, which in this case, if I go ahead and just do, and I'm going to scroll down here. If I scroll down to a problem that, again, I had done in the YouTube video last night, like, for example, number 7, I guess. Number 7 in the YouTube video, I did log base 4 of 12, and that was equal to 3x. So that was just us rewriting, using this exponential to start, as a logarithmic log base 4, because that is the base, of 12, and that equals the exponent 3x. So as far as what we're going to type in, yes, you can use this, what I call change of base formula, which I'm going to talk more about later today. But you could also, if you have the button in your calculator, type in log base 4 of 12. The calculator nicely will do it for you, for those of you that have it, and you get this particular value. Now that's not it. We're not quite done. 1.7925 is now set equal to 3x, as you guys see right here, and then I divided by 3. To kind of finalize it, just divide by 3. Never round in the middle of the problem if you can avoid it, and your final answer to this question was 0.5975. That's precisely what I had done in our YouTube video prior to this. Other things that I did in the YouTube video is I did problems 1, 3, 6, and I also did not just 7, but also number 8. I asked my kids to do numbers 9, 11, and 13. So to kind of kick things off today, I'm going to go ahead and do number 9. So everybody pay attention. We're going to take a look at number 9. And here's how it's going to look. So first we can see that 5 raised to the 4x minus 2 equals 120 is the beginning premise. So let's rewrite this as a logarithm. So log base 5 of 120, and that equals 4x minus 2. This shouldn't be a surprise. When it comes to understanding and interpreting, again, an exponential converted to a logarithm, this makes sense. Here's the problem. 5 to what power is 120? Well, I don't know. 5 to what power is 120? Okay, so here's what we're going to do. We're going to use something called the change of base formula. I don't care what kind of calculator you have. You guys do have the capability, whether it's your cell phone or an older scientific calculator, or even a TI-83, for example. So let's all write this down. We're going to go ahead and take log of 120 over log 5. Now, although I did show this to kids in the last YouTube video, I do want to reiterate that this is another option for us. No matter what calculator you have, everybody can do this. I'm going to formally introduce this, though, kind of on the next page, but still, I want you guys to take a look. So let's do this. So log of 120 divided by log of 5. And then, of course, well, because it's still equal to 4x minus 2, I still have to solve for x. So get your calculators out and let's do this. So log of 120, make sure you close the parentheses up, divided by log of 5. Now, if you do have that special, and there's the answer, by the way, but if you do have that special feature on your calculator under the Math menu, you could go up to Math, or up to log base under Math, and you could type in, if you want, log base 5 of 120. It should not be a big surprise whatsoever. The answer is still 2.9746-ish. What we're going to go ahead and do now, of course, because we're not done, is we're going to solve for x. To solve for x, I'll take the answer that I just got on my calculator without rounding in the middle of a problem, which you don't want to do. I'm going to add 2. Take that decimal, divide by 4. Our final answer should be 1.2437, and that's what I'm going to write. X is roughly 1.2437. Now to check our answer, and I know you guys remember that it's good to check answers. Technically, you don't have to in a problem with an exponential to start with. On a log equation problem, you really have to. Here you don't have to, but I do want you guys to see that it does work. Remember, the original problem was 5 to the 4x minus 2 equals 120. So let's take our answer, saying that 5 raised to the, and I'll use parentheses because everybody doesn't have the exact same calculator as I do. 5 raised to the, 4 times answer, I'll hit second answer, minus 2. Before I hit enter, go ahead and type that in as well. 5 raised to the 4 times answer minus 2, it should be, and it is, 120. Okay, so let's take a look. So we start with 3.6 raised to the 4x minus 1, and that equals 85.4. So if I rewrite this as a logarithm, it'll look like log base 3.6 of 85.4, and that equals 4x minus 1. No big surprise there. In order for us to solve for x, we do need to first implement this change of base formula, which means that log of 85.4 over log of 3.6 will then be set equal to 4x minus 1. So we'll use our calculator here because we can't really otherwise come up with the decimal. Log of 85.4, and the base here should be noted as 10. Anytime you have just log sitting there, that base is implied to be 10. Divide that by log of 3.6, and that decimal should end up being 3.47, we'll just say 1 or 20, 3.4720. Now, I did note that rounding in the middle of a problem is a bad idea, but I'm just going to write it down. I'm not going to actually use this decimal in the next step or two. 3.472. I do need to solve for x, so I'll add 1, keeping that number on my calculator, simply plus 1. And last step, divide by 4. So I'll kind of do 2 steps in one, highlighting my final answer as 1.1180. All right, we'll go ahead and highlight this as our final answer, and yes, we could check it again by taking 3.6 raised to the 4 times the answer, and then what? Minus 1, correct? All right, we do that, hit enter, and it should end up being the original thing or number that I was taking the log of, 85.4. To kind of finish things up here today, I'd like us all to take a look at the back side. On the back side, it does formally introduce the idea of the change of base formula and how it could be implemented. So I'll walk you through at least the example, and then your homework for tonight. The following formula is used to change expressions with different logarithmic bases to common logarithmic expressions. It is formally now referred to as the change of base formula. For all positive numbers a, b, and n, where a is not equal to 1, b is not equal to 1, log base a of n is equal to log base b of n over log base b of a. I need everybody to circle and highlight n in the context of the change of base formula. That is the numerator quantity. And as far as the denominator quantity, that is the official or original base. So log base b of n divided by log base b of a. For example, express log base 8 of 15 in terms of common logs and then round to the nearest 10,000. So if I ask you to take log base 8 of 15, you could rewrite it as log base 10 of 15 divided by log base 10 of 8. Let's circle the 15, and there it is there. Let's circle or highlight the 8 and highlight it, of course, there in the formula. If you guys type it in and you don't need to use a base at all, just type in log of 15 divided by log of 8, and let's take a look. Our final answer, rounded to the nearest 4 decimals, is in fact 1.3023. Final answer as you see it right here, and that should do it. So your homework for tonight is to finish the following problems.